Okay, on.
Hello, me Avanatsa. Yeah, I'm going to discuss binomial theorem for positive integral index. Integral index only not for only first of all positive integral index. So first of all we try to know what is positive integer. Positive integer. I think all of you know this. So simply positive integer means we are going to denote by z plus or I plus. So positive integer are nothing, simply whole numbers like this one, 2, 3, and so on. So positive कहाँ तक हो गई यहाँ तक?
Yeah, okay, sir.
So positive integer means only the numbers 1, 2, 3, 4, 5. So it does not include decimals like this one 0.5. This is not a positive integer. 1 by 2, this is also not a positive integer, and this is how much here -8, this is also not a positive integer. So we should not be confused. Positive integer means simply 1, 2, 3, 4, and so on. So 0.5 not a positive integer, 1 by 2 not a positive integer, -8 not a positive integer. So we are going to deal binomial theorem for only today is how much positive integral index. So these are the positive integers. Now let us do this one. Over here, now let us start. If n is a positive integer, then what we can get over here? Then a plus x to the power n, to the power n. This expansion expands as how much here? nc0 a to the power n plus nc1 a to the power n minus 1 x to the power 1. Third one, how much here? nc2 a to the power n minus 2 x to the power 2. nc0 a to the power n. Second term nc1 a to the power n minus 1 x to the power 1. Third term nc2 a to the power n minus 2 x to the power 2, and so on. This power is n. So this one is the term is coming. The last term is coming how much here? ncn a to the power n minus n, and this is how much here? X to the power n. So this expansion is known as binomial expansion for positive integers. Clear? So first up nc0, nc1, nc2, ncn. Okay. So one thing more over here, not to be confused. nc0, we are writing this is how much here? cn0. Similarly, ncn means how much here? cn comma n, and so on. So this one is the binomial expansion. Okay.
Okay. On.
Expansion a plus x to the power n. So few properties we are going to deal about the expansion a plus x to the power n. So just first of all, we follow over here. If n is a positive integer, then the expansion is a plus x to the power n. The expansion is nc0. So first of all, what we observe over here, the power is n. Power is n. So first property, power is n. The total number of term in the expansion is n plus 1. if the okay. नेपाली में नेपाली में केंद्र
Kenga?
So properties of binomial expansions. Over here the expansion a plus x to the power n is the expressed over here we can see. So first of all, first property we can deal number of terms in a plus x to the power n is n plus 1. So number of term is one more than the index. As for example, we can take, so we have done, this is how much here, a plus x to the power 3. We remember the number of term is how much here, number of terms is 4. That means 3 plus 1. So for all the expansions, if power is n, the number of term is one more than the power. Means index is 5, then the number of term is 6. Index is 6, then number of term is 7. So one more than the number of terms. So this one is, we are going to do, this is the first property. Second property. So observe only over here. So a plus x, the first term is a, second term is x. So look out the power over here. First term, the power is n. So the index, total index is n, so power is also n. And over here we can write x to the power 0 also. Second term, power is how much here? LC1. Second term, power is n minus 1. X to the power is how much here? 1. Power is a to the power n minus 2, x to the power 2. NCR, this is R, so NCR, n minus R, n. So simply we can observe the first term, the power of the first variable, means first term is decreases by unity. Decreases by unity. N, then n minus 1, n minus 2, n minus R, and so on. Second term, the power is increases by 1. The power 0, then after how much here? 1, then after 2, and so on. As for example, we can take. So let us take an example, then after we can define. So a plus b to the power 3. A simple example, we know this one. What we are writing over here? A to the power 3. Second term is how much here? 3, a to the power 2, b to the power 1. Third term is how much here? 3, a to the power 1, b to the power 2. And last term we are writing b to the power 3. Means simply we are getting first term the power is 3, second term 1 less 2, third term 1 less 1, and last one is 0. Similarly, second term b power is 0, over here 1, 2, and 3. So simply we have to know the first term the power is decreases by unity, and second term the power is increases by unity. Power of first term a